Okay, linear programming. This is the last section in Unit 3. Okay, so first, just determining a maximum and a minimum. A convex polygonal region has these 4 vertices. Minimize this function C. Now, this is going to seem when we do it like, all right, this is simple. Why do we even have to do this? But this is one of a very important technique in calculus. Just getting vertices, understanding them, plugging them into a function, and determining a maximum or a minimum. So, very simple chart we'll set up. Here, each of my vertices, 0, 8, 2, 5, 4, 3, 6, 0. And then this is the function that I want to minimize. So if we just think rationally about this, if I have coordinates, then I have values for x and y. So I'm going to plug those values in for x and y. So I would like you, for homework, to complete this. Okay, evaluate this function C for each of these 4 vertices, and then conclude where the minimum occurs. Okay, so linear programming, lots of steps that we can identify, but you're going to see as you get into the problem, I'm not going to look specifically for you to write down all 8 steps, but I am going to use them as we do the first example together. Okay, you'll see that a couple of them might fit together. If some make more sense for you to do at different times, then that's totally fine. Okay, so in your notes packet, I took the example from the last slide. This is what I'm going to do on the video because it's a little bit easier for the first time you're going to see it. And then the one that you have listed on the second page of your worksheet, that's what we're going to do in class. Okay, so it takes 2 hours to make a circular rug and 1 hour to make a rectangular rug. At most, you have 12 hours to devote to rug making each week. Both circular and rectangular rugs take 1 pound of wool. There's at most 10 pounds of wool to use each week. If the profit on a circular rug is $7 and the profit on a rectangular rug is $6, how many of each should be made to maximize your profit? Okay, so first step. Identify your variables. So I'm going to use C for my circular rug, and I'm going to use R for my rectangular rug. Now, you can use X and Y every single time. Just make sure you know which one actually goes with which part of the problem. Okay, so create a chart. And this is one of the things where you may or may not use this as you're doing the problems together, but as you're learning it for the first time, I think it's it's a good way to organize what's going on here. I would say start with your limits, okay, because your limits are going to be able to determine where, sort of set up the equations that you're going to need. So your limits are that you have at most, so you've less than or equal to 12 hours that you can use to actually make the rugs. And then you have at most 10 pounds of wool to create the rugs. So as you're setting up the inequalities that you're going to have to graph, so where does the time come from? The time comes from creating each type of rug. So my variables here, my circular and my rectangular, these are what's changing, okay, according to what goes into creating them. So my time, circular takes 2 hours to create each one of those, 1 hour to create a rectangular. Both rugs take 1 pound of wool, so the amount of fabric that's needed, 1 pound for circular, 1 pound for rectangular. And the goal for the chart is that you're setting up using the units. So if hours is a limit, then I need to add the amount of time it takes to make each type of product, in this case rugs. My other limit is the amount of fabric I can use. So I have to look at the amount of fabric used for each type of rug. Okay, now these are limits: at most, at least, no more than. These are inequalities. So our system of inequalities using the chart, okay, first I'm going to write the inequality for the amount of time. 2 hours per circular rug plus 1 hour for every rectangular, and that has to be less than or equal to 12 total hours. Next, 1 circular rug plus 1 pound of wool on the rectangular rug. That is at most 10 pounds I have available to me. And then you do need to include these next pieces, okay? The amount of rugs that I make have to be positive, okay? So we will be looking that you put that information. So R has to be greater than or equal to 0. C has to be greater than or equal to 0. So this is the system that we are then going to graph. Okay, so I have 2C plus R is less than or equal to. I have circular plus rectangular is less than or equal to 10. Now the significance of these two pieces of information, notice the graph I give you. It's all in the first quadrant, okay? So I'm going to make my x-axis the values for C, my circular rugs, and I'll make my y-axis the values for R, my rectangular rugs. And if they both have to be positive, then it just restricts my graphs in the first quadrant. Okay, so these are linear functions. All right, if we just want to do simple x and y intercepts. So if C is equal to 0, R will be equal to 12 on my first inequality. And if R is equal to 0, then C would equal 6. Okay, so those are just my x and y intercepts. So this is the point 0, 12 and the point 6, 0. And notice C, again, I identified that as my x value. So 1, 2, 3, 4, 5, 6, 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 12. Do these in class and you can use a straight edge to connect them. It helps you that much more with finding the point of intersection without having to do much more work. Okay, using the same, I'm going to find my x and y intercepts for my second. So when I'm not making any circular rugs, 10 for rectangular. If I'm not making any rectangular, 10 for circular. So 6, 7, 8, 9, 10. And then this was 12. So this would be 0, 10. Okay. So I'll use a second color to connect those intercepts. Okay, so now that I have my two graphs, now I find the points of intersection. These will be the vertices of what we call our feasible region. So the feasible region would be the region that satisfies all the inequalities. That's why we had less than 3, 3 before this. So bigger than R, or R is bigger than 0, C is bigger than 0, but I have to be below both of these conditions. So my feasible region here, these would be the ordered pairs for my feasible region. Okay, so if I just look at shading, so the origin, 0, 0, I have the y-intercept of 0, 10, the x-intercept of 6, 0, and then we need to find this ordered pair. Now, again, if this is graphed perfectly, I mean, it does end up being 2, 8. But if I didn't know that, how do we solve this? Well, this would be a system of equations. Okay, so if you can't identify it from your graph, you still need to know how to find the points of intersection. All right. Fortunately, R is the same, so I'm going to subtract these. 2C minus C would give me C. R minus R cancels. 12 minus 10 gives me 2. So it verifies that C is equal to 2. And then if I have the 1 value, I plug it in to find the other coordinate. Okay, so it verifies the point of intersection which we would have found from the graph, which is 2, 8. So that would be the last vertex of my feasible region. Okay, so the next step, determine the max or min equation for either the profit or the cost. So let's go back to the problem. The profit on a circular rug is $7 and on a rectangular rug is $6. So how many of each should be made to maximize your profit? So we could actually add on our original chart a line for our profit. And it doesn't have a limit to it, but again, it keeps all of our variables together. So $7 on circular, $6 on rectangular. Okay, so my profit in terms of my circular and my rectangular rugs, $7 for circular plus $6 for rectangular. Okay, so now when I substitute the vertices back in to find the maximum, this is the very first example we started with. Here are my vertices. Here's my profit. And I take these points from the feasible region, and they're going to be the points that I plug into my profit equation. So I have 0, 0, 0, 10, 6, 0, and then 2, 8. Okay, so this obviously would just be a profit of $0. That doesn't make any sense. So I would have 7 times 0 plus 6 times 10. So this would give me $60. 7 times 6 plus 6 times 0. So this would give me $42. 7 times 2 plus 6 times 8. So 14 and 48. This would give me $62. Okay, so if you weren't able to do the first example or didn't know how to start, this is exactly what you would do. So now if I'm looking for the maximum, I'm literally just comparing my outputs. The biggest Y value, the biggest answer is $62. So now my final step to actually write my conclusion. So the maximum profit of $62 is earned when I go back, 2 circular and 8 rectangular rugs are made. So when 2 circular and 8 rectangular rugs are made. Okay, we'll talk about this in class. And for homework, I would like you to read this program and just complete steps 1, 2, 3, and 6. Okay. So those steps are step number 1, identify your variables. Step number 2, create your chart, write your system, and then write your profit equation. See you in class.